This is recording 2 for topic 6, correlation. Okay, we just looked at the formula, and now we're going to walk through calculating the covariance of X and Y. So first, for some reason, this is X bar and this is Y bar. This never comes out in my PowerPoint. So this is a deviation of X times a deviation of Y. Okay, let me get a better color here. Okay, so first we're going to calculate the mean of X, right? And I've actually done that, but it's 1 plus 3 is 4 plus 4 is 8, 10, 16, 21, right? And we'll do the same for Y. So we have the sum of X is 21, sum of Y is 27, their means. Okay, we have the mean of X equals 3.5, the mean of Y is 4.5. There we go. Let me get a different color here. Okay, then we have to calculate the deviation. So here we just do 1 minus 3.5 is negative 2.5. 3 minus 3.5 is negative 0.5. 4 minus 3.5 is 0.5. 2 minus 3.5 is negative 1.5. 6 minus 3.5 is 2.5. And 5 minus 3.5 is 0.5, right? We can make sure that we're correct by making sure these add up to 0. Let's see, negative 2.5 plus 2.5 is 0. And then we have negative 5.5 plus 0.5 is 0, right? Well, this is 1.5. Yep, see, it already made a mistake. Negative 1.5 plus 1.5 is 0. So 5 minus 3.5 is 1.5, right? It's always a good idea to add up the deviations and make sure they add up to 0, right? Okay, so finally we do it for Y. So 8 minus 4.5 is 3.5. 4 minus 4.5 is negative 0.5. 5 minus 4.5 is 0.5. 6 minus 4.5 is 1.5. Oops, 1.5, right? 2 minus 4.5 is negative 2.5. And 2 minus 4.5 is negative 2.5. All right, so let's add this up. Let's see, 3.5 minus 0.5 is 3, plus 0.5 is 3.5, plus 1.5 is 5, minus 2.5 is 2.5, minus 2.5 is 0, right? So these add up to 0 too. Now we have to multiply the deviation of X times the deviation of Y. So 2.5, negative 2.5, negative 2.5 times 2.5 negative 2.5 times 3.5 actually, right? This is the 3.5, that's equals negative 8.75. All right, that's right there, that's the answer. Negative 0.5 times negative 0.5 is 0.25. 0.5 times 0.5 is 0.25. Negative 1.5 times 1.5 is negative 2.25. Remember here, negative times a negative is equals a positive, and a positive times a positive equals a positive. The only thing that equals a negative is a negative times a positive. So 2.5 times negative 2.5 is 6.25. And 1.5 times negative 2.5 is negative 3.75. Right? Now we need to add these guys all up to get this, right? And we're going to proceed to the next slide where I have some of that written out. Okay, so here's all the work we just did, right? This is, okay, this is the sum of the deviation, right? This is the right up here. It's negative 20.5, and then you divide it by n minus 1. So n is 6, minus 1 is 5. So negative 20.5 divided by 5 is negative 4.0. So this is equals negative 4.0. 0.10. It's a negative correlation. We can already tell that, right? Okay. So let's continue. We plug that in, right? So here's the covariance. I gave you right here the standard deviation of X because I don't want to ask you to calculate it. You already learned how to do that. The standard deviation of X, the standard deviation of Y, right? So that's 1.871 times 2.345, right? It's right here. And we get negative 0.935. All right, that's how you calculate it. But I'm not going to actually ask you to calculate it. We'll use software to calculate it for us, SPSS. Okay, so we're also going to talk about Spearman's rank order correlation, which can be denoted R sub S, or sometimes people say rho. Spearman was another super important person, okay? Not only did he provide this calculation for the relationship between ordinal variables, but he also did a lot for intelligence testing. He talked about the G factor, which if you've taken general psychology, you will have heard of this, right? In any case, the Spearman's correlation coefficient is used when you have an ordinal variable, when you need to do a correlation between an ordinal variable and another ordinal variable, an ordinal variable, or an interval ratio variable. It's also useful for very skewed scale or interval ratio variables, okay, because it's a non-parametric procedure, which compensates for that big skew. But we're not going to talk about that in this class, okay? Spearman really was important in developing factor analysis, again, because he had his theory of intelligence had a G factor and a whole bunch of specific intelligences, but that's topic for another course, okay? So here's an example of an ordinal variable and the scatter plot of an ordinal variable, which is political orientation, and a continuous or interval ratio variable, which is the support for traditional values on the y-axis. And you can always tell when something's ordinal because you'll see how there's very few discrete, remember these are discrete values on X. So 1 was very liberal and 7 was very conservative, and people could have just had answer 1 through 7, right? Traditional values was scored how much do you support traditional values, and you pulled the bar from 0 to 100. And we can see that looks like there is a positive correlation here because there are no low value support for traditional values at 7, and there's very few high values at 1, which was very liberal, right? So we know how to do this, right? We can now run a Spearman's correlation, right? And we can see that, yes, there is a pretty strong positive correlation between the two variables, a 0.571. All right. There we go. Okay, so notation, R equals 0.52 for Pearson, rho equals 0.20 for Spearman. This is a Greek letter rho. You can also use R and a subtext of S for Spearman if you want, okay? For the rho, you have to use insert symbol or tick on the 3 little letters in Canvas, 3 little dots to the right in Canvas. Make sure you italicize R's. Yeah, R for Pearson's R, any M or anything that our letters are. We do not italicize Greek letters. They do not have typewriters, right? Some people do, but don't do it, okay? So how should we interpret correlations? This is just as important. Like I said, they range from -1 to 1. The closer to 0, the smaller. The closer to 1 or -1, the absolute value of 1 is large, right? We just have to use context. So as researchers, we look at previous literature, that is what's already been published, what experiments and other empirical data have already been published. And then does it really matter, right? So let's look at some examples. Your classic example is that of aspirin therapy and reduction in heart attacks. So they used a large-scale double-blind study to study. The double-blind just means that neither the researcher nor the participants know what condition they're in. So they didn't know if they were receiving the actual aspirin medication or a placebo, right? They terminated it because the results were clear that aspirin was very effective in preventing heart attacks, okay? It wouldn't have been ethical to continue to give half of them a placebo. So how large was this correlation? It was tiny. R equals -0.03, okay? So we have aspirin use and reduction in heart attacks. And if this was a really expensive drug, maybe it wouldn't be worth it, but it costs pennies, right? Another way to reduce heart attacks, just walk 30 minutes. That's even cheaper. You don't even have to go to the drugstore to get it. But of course, it's easier to pop a baby aspirin than it is to walk. So this is a really important study. And even though this correlation is very low, it's over millions of people, we prevent a lot of heart attacks, right? So this is negative 0.03, but 3%. So three out of 100 possible heart attacks, 3 will be prevented, right? Out of 1,000, 30. Out of 10,000, 300, right? Pretty soon, when we have millions of people or billions of people, it's pretty evident that it is an important correlation. Let's look at a few more, however. Okay. SAT and first year GPA, SAT scores. So this is a pretty strong correlation. It's interesting given that many universities are saying they're no longer going to take SAT and scores into consideration, which in my opinion as a psychometrician isn't the best idea because standardized tests are one of the least subject to bias. The best predictor is pretty much school district. And as you may know, school districts depend on funding of the people who live there. So very much influenced by socioeconomic status. Anyway, off topic. Smoking, lung cancer, R equals 0.40, again, important. Media violence and aggression, 0.32. We'll talk more about that with our examples, right? But this is media exposure, media violence, not necessarily video games, let me tell you. Self-examination and detection of breast cancer. So again, this could be important because it is important. Exposure to lead and IQ scores, not very strong, negative 0.12. But if you're like me, you don't want to sacrifice even a tiny bit of your IQ. I need all the help I can get. So what I don't want is having my children have a little bit less IQ because they're exposed to lead, right? So really, it's all about context, okay? So moving on. So let's, I have one more example here. What if SAT GPA correlation was R equals 0.07? Well, nobody would really care, right? But because it's big, 0.47, people do care, but not enough perhaps. All right, moving on. So here's an example of a table from published work. Okay, so I just want to show you what it would look like if you find it in a journal article. So these are the correlations here, right? Okay, we have the scale used to measure different things right here. Okay, we have a title. Then we have a note, which we'll talk about later, right? So one is a number of young adult fiction authors people recognized, fiction authors, nonfiction authors, empathic concern, and so forth. The correlation of something with itself is always 1. So we usually don't put that in the table. But then 2 would be fiction, right? 3 is nonfiction, 4 is empathic concern. And it's usually reported in the upper triangle like this, but you could also have it in the lower triangle, right? So for example, the correlation between empathic concern and moral self, well, we have to go over here to 7. It's right here, 0.390, all right? Here's another type of table you might say. Again, this is my table, so I use the upper quadrant, but some people use the lower quadrant. Here we have the correlation and a 95% confidence interval. Okay, we're going to talk about confidence intervals later, but a summary is that the Pearson's R is a point estimate. We can base our inferences we make about the population on that point estimate, whereas the confidence interval provides a range of values that we can expect the true correlation in the population to fall within. So within 0.76 and 0.85 here, right? So this table has the point estimates and the 95% confidence interval. It also has the median, okay, and the mean, okay, which tells you something. It tells you that these two, this one is pretty normally distributed, right? But this one, for example, has a positive skew, it looks like, right? And this is also Cronbach's alpha, which is a measure of internal consistency for the scale. We'll talk about that if you take research methods, all right? So here's what the output looks like in SPSS. And I'm going to talk all about this when I give you in the SPSS instructional video, which is in fact already recorded. So you can get the descriptive statistics if you want, and it has for in this one, I entered 3 variables, but you will be generally just entering 2, right? gives you mean, standard deviation, and the number of people that answered each questionnaire. So you can see that fewer people answered the aggression questionnaire. And again, this is because people, when it's something that is a sensitive topic, such as how aggressive are you, or maybe domestic violence, there are going to be people who just skip the questions, just refuse to answer, right? So that's part of what contributes to the restriction of range. Some people just de-emphasize their aggressive qualities, and others just refuse to answer, okay? So here's our correlation table. So SPSS, sometimes it gives you both quadrants, the exact same correlations, but I'll show you how to select, so it just gives you the bottom here. And the correlation, the one you're interested in, is the one that's right across from Pearson correlation, right? So here, negative 0.298. This value we'll talk about later. This is the sample size, okay? And the way you report correlation is R, and then you put parentheses in the degrees of freedom, which is N minus 2. Degrees of freedom for correlation is N minus 2, so 357 minus 2 is 355. Equals negative 0.298, negative 0.298. All right, that's how you report it. And that's the SPSS output. If you wanted to find the correlation between openness and MIQ, which is moral identity, you just come over here and it's 0.101. Okay, so for openness, our degrees of freedom here, it's so for this correlation, it's 381. So N minus 2, 381 minus 2 is 379 equals 0.101. All right. More on that in the SPSS instructional video. If you've got any questions, please post them in FAQ and read your book, and finally email me.